It's about 1:30. We should get started. I just want to welcome everyone. And my name is Rick Loring, a Division Sales Director with Maya here in the Northeast US. Thanks for joining us today for a brief look at the Solid Edge Integrated Electrical System portfolio known as IES. We'll also be taking a look at the Solid Edge wiring and harnessing tools, which are part of this suite. Maya HTT provides software-driven engineering solutions, and as a matter of fact, we've been awarded the #1 worldwide partner for Siemens this year. We're a collection of passionate engineers. About 75% of our staff are actually scientists and engineers. Although we started in space, we're recognized worldwide for our multi-physics simulations. Our engineers have hands-on experience in almost every industry. We've developed over 30 software modules for Siemens and now have millions of users around the world. We help our clients put satellites into space, reduce energy consumption in data centers, design zero emissions vehicles, and find better ways of doing engineering. We're joined today by Mr. Mohammed Omar from Maya. He'll give us a glimpse of the evolution of this technology, as well as a demonstration of the software. So post any questions as we go along in the chat window, and we'll have a Q&A session at the end.
Hello, welcome to this presentation. My name is Mohammed Omar. In this presentation, we will look at solving the challenges of electrical complexity. We're going to discuss briefly the evolution in the electromechanical industry in general. From there, we're going to see how solid edge wiring and harness addresses those challenges and how it helps users to essentially cope with the complexity. And then we're going to summarize the presentation, and after that, we're going to open the door for questions. We all have read about or even witnessed multiple advancements. Some are slow and some are incredibly fast. Getting on board and leveraging those advancements can make or break a company or even a technology. For example, this is a photo that was taken on 5th Avenue in New York in the early 1900s. What you see here is that the whole street is filled with the method of transportation back then, which was the horse carriage. But if we look closely, you notice that there is a new kid on the block, which is a car. Now, is that car the most efficient mode of transportation in that ecosystem? Probably not. However, if we look at the same street only 13 years after, there is but a single horse on the street. Only in 13 years, cars went from a nice to have to an essential part of the system. So this leaves us wondering, what happened to the horse and horse carriages and technician suppliers that used to prosper back then? So that was almost a century ago. Does this still hold true in our timeline? So we're looking at a picture of St. Peter's Square in 2005 during one of the Pope's inaugural speech. Notice that at the bottom right of the screen, there is a person with the latest technology back then, which is a Motorola flip phone. Again, not exactly sure if the quality of the picture or recording is worth a while, but still, it's a flip phone nonetheless. Now, the same ceremony, but only 8 years later. This little cell phone is now everywhere, as we can see, but there is a new kid on the block, and it's the tablet. One could again question its utility back then in 2013. But what this tells us is that we're still evolving, and we can observe evolution in all faculties of life. So it's no surprise that the automotive industry is growing exponentially, and so is the technology. For example, this is a luxury sedan used to look like in 1980. And again, we can take multiple looks or multiple examples. And this is what they look like today. Digital screens, devices all over, different types of sensors from parking, cruise control, radar, and so on. The evolution is increasingly faster to the point where, on average, for a modern vehicle, The wiring harness is the heaviest component after the engine and chassis. And of course, the evolution is reflected on the electrical wiring and harness design. For example, according to BMW, there are over 50 million configurations available for the BMW 1 Series. For example, if you take a look, this is a simple harness of maybe a traditional car in the 90s, early 90s, late 80s. But if we take a look at, this is the wiring and harness of the 2019 Bentley Bentayga. So we can see the amount of wires, the amount of complexity available when we compare it with what we just saw. And this applies to all industries, which is a challenge of more complex harnesses and electrical distribution systems. Therefore, the electromechanical design of modern or in modern products is extremely important. So, unfortunately, the evolution is one side effect of a common industry trend. Electrical content is always increasing regardless of the industry and the application. This increases the cost to do the initial design as well as to manufacture the harness, for example, for the prototype. Also increases the overall design time due to the complexity. And similarly, every time something new is added to the design, the chance of inducing an error becomes greater and greater, and it comes along with changes that you might happen to the design. So now let's learn about solid edge wiring and harness and how it addresses the impact of the growing electrical contact and how it addresses the growing complexity of systems. We're going to break down the tool into 5 main categories. The first one is going to be components. We're going to see how Solid Edge helps you maintain an up-to-date component libraries as well as establishing the links between those components. We're also going to take a look at the design management. And of course, once you have the first version of your design, we'll discover how you can validate your design with the different simulation tools available off the shelf within Solid Edge wiring and harness, in addition to tracking and exchanging notes and comments in different engineers and technicians in the working design. We also take a look at ECAD and MCAD collaboration. Electrical engineering is inherently a multidiscipline. It's inherently a multidisciplinary field. Integration must be provided with adjacent activities such as mechanical designs, bill of material consolidation, manufacturing operations, and supply chains management. Solid Edge is built to integrate through data exchange with adjacent domains using industry standard formats. And we're also going to take a look at the automation, electrical design, optimization, verification, and engineering is now only feasible using an integrated data-centric tool delivering substantial automation. Errors and insignificance and inefficiencies are avoided, and engineers are free to create for creative problem solving. Solid Edge digitalizes the electrical domain and creates the electrical distribution system digital twin upon which unique automation is delivered, reducing development cost and cycle time and for more functional products. And finally, we're going to discuss the native reporting functionalities or features in Solid Edge, as well as building reports on the fly. So let's start by talking about components and component links. Components in Solid Edge wiring and harness are categorized into 3 main folders: the component folder, codes folder, and companies. We're gonna start with the easiest one, which is companies, which is straightforward. It has 2 subfolders, customers and suppliers. Essentially, as the name explains, you have a list of all the customer contacts, preferences, settings, stuff that they can specifically use, part numbers, and suppliers, and the same thing applies for the suppliers. And then you have the codes, and the codes are essentially used by Solid Edge wiring and harness to build your standards in the specific organization, whether from color codes, material codes, property codes, pitch definitions, manufacturing sites, and so on. So Solid Edge enables the company to essentially establish its standards in the tool itself, and it's adopted in the database. As a result, all the components that you define in the last type, which is the first one in the tree here, is the components folder, those components are going to adhere to the codes that you already predefined. And the components folder allows you to add more components, to add new components, to copy component details from one group to another, or component deletion in case some components went obsolete or so on. So the other part, or the important part of the data or of solid edge wiring and harness database, is that it enables users to establish component links. And component links allows the users to streamline time during their design. So because from our experience, most engineers that we come across are using non-dedicated tools for electromechanical designs, such as Excel or Visio, and they don't offer intelligence and more or less are just drawing tools. So what sets Solid Edge apart is that it's not just a drawing tool. It's a digital twin of your design, and the digital thread extends all the way from your component database to your design. So for example, let me explain this slide. You create your own devices. For example, you have a list of your devices in your database. Within those devices, you can associate a list of or a group of connectors that are always preferred to be used with this specific device. And each connector could have a group of terminal seals and plugs that are always also used with it. And those are essentially called cavity components. And each cavity component is assigned to a group of wires. So how this translates into the design is that instead of building each component, each device, and then selecting connector, terminal, so on, you just select the device and Solid Edge will automatically fetch all that information from the database into your design. So let's see how that is done in the tool itself. So in this video, what we're going to do is we're going to briefly introduce the component maintenance dialog, and then we're going to demonstrate how to establish those links into Solid Edge. Once you launch the component maintenance dialog, you can see the three components or the three folders: the components folder, the codes folder, and the companies folder. And again, the codes is where you define your standards. Once you launch the component maintenance dialog from the components group, we're going to add a new component. We're going to select it to belong to the group connector, and we're going to assign a part number for this specific connector. And then we're going to use the user interface to add a description. So it's just going to be a 5-pin connector. We're going to set the number of pins to 5. We're going to specify using the codes that we define, the type code, the color code, the material code, which allows you to sort your components and to create subcomponents within or subgroups within the group itself. So if for a connector, you can have multiple types. Solid Edge also allows you to add the housing components, for example. So in a connector, this is where we're going to define our terminals. So for example, here we're assigning a specific terminal to be used with the connector that we just created. It automatically searches the database. We can search by part number. Once we finalize, we set all of settings for that specific terminal. We apply it, and you can see that it's now listed in the housing page. Now we're going to do the same thing, but we're going to create a device. So we established the link between a connector and a terminal. Now we're going to establish the link between a device and a connector. So we created a device, assigned a part number, assigned a description for the device. And we're going to again leverage the codes to define the type code, color code, material code, and the number of pins for this specific device. And again, you can use symbols in Solid Edge wiring harness to control how it looks, how the device or component or connector looks in the design. We can also assign components to it, but what we're going to do is now establish the link with the connector that we used. So we're going to create a footprint, and we're going to assign a part number, which we know from our database. It's connector 01, which is the connector that we just created. And we're going to assign it to that connector. And we're going to expand the mating so we can see how it mates to the pins and cavities of the device. And we have a map of that mapping of that mating essentially that we can edit. So let's take a look at the definitions of the device that we just created, or essentially the connector that we just assigned. Once we open the definition of that specific connector, you're going to notice that in the housing tab, we have our terminal that we just assigned. So this is a very smart way to establish links between your components and to streamline this in the design. Once you do it once in the library, it was going to save you time in the design itself, since you don't have to manually add those components. So next up, we're going to discuss the design verification. So once you have your first design, you'd like to move into the next stage, is to verify the design, make sure that everything is operating as intended. So in this specific video, we have a design of a wiring harness for an electric vehicle. We have a battery, an ignition, alternator, and so on. And you can see that there are three systems that are dependent on this specific diagram, which is the instrumentation, power takeoff, and lighting. So let's take a look at the lighting diagram. You're going to see you have multiple select switch, you have connectors, splices, resistances, and even lamps and connectors, and even grounds connected to the chassis. Now, what we're doing here is going to activate the analysis mode, and we have two modes of analysis that we're going to explain as we progress. We're going to select the qualitative one, which just gives us an idea of what's happening, and we can immediately see the diagram moving into a cyan color, which indicates that there is no current flow. So we can select multiple positions for the select switch, and now we can see portions are moving into green, which tells us that there's a current flow in those specific wires. We can simulate faults. We can also hover over a connector and select the different positions that we can. We can go back and see in the main, we can see the power coming from the battery going into the solenoid, but we can see that the light is not going. There's no current to the lighting. So we can select multiple switches. And now we can see now the power is diverted in the instrumentation panel and so on. So we're just testing the different settings, the different positions for the ignition switch, just to understand how it operates. And from there, we can go back to the lighting system and select another position for the light select switch. And now we can see the current is flowing. So this gives us an idea of what's happening. Now we're going to move into a more detailed analysis type, which is called the numerical analysis. This allows us to get more information like the current flow in the wires, the rated current of the wire, the voltage drop in the wire, the resistance of the wire, the temperature of the wire. All this information is available from the definitions that you have in the library database. So solid edge wiring and harness utilizes this data to show you quickly what's happening. And we can also simulate like short circuit and failures in our systems. And just as you hover over the specific component that you'd like to know the more information about, it gives you a list of such information. Again, here we go back to the main challenge of the electromechanical design in the industry, which is ECAD and MCAD collaboration. The nature of the engineering process is a multidisciplinary process where multiple engineers and technicians are working on the design, and therefore being able to exchange the data between all teams involved is of the utmost importance for a better and a quicker and less risky prone design. So the ECAD and MCAD collaboration, when we break it down into main three sections. We have the wiring design, where you just develop your schematics, which is usually done by the electrical team or the electrical engineers. And then we move into the actual 3D CAD electrical routing or 3D CAD modeling, which depicts the actual physical length of the model, whether you're designing an electric vehicle or even designing a coffee machine. You have to have some physical representation of that specific device. And again, the harness design, which is called a nail board, to actually manufacture the schematics that you just developed for those components. So let's see how solid edge wiring and harness and how the different IES portfolio, which is the integrated electrical system portfolio, address such challenges of ECAD and MCAD. The first step, we're going to use the wiring design to develop the wiring components, for example, the schematics into the 3D world. Then the mechanical team usually imports this data to calculate the wire length, to calculate the actual distances between and the positioning of those different components in the actual physical diagram or the actual physical model. And that data is sent back to the electrical team to use those wire lengths to calculate voltage drops if the device, if the application is sensitive to voltage drops, for example. So, and this, of course, this process is repetitive until you finalize the design and you reach the point where you have confidence in and you achieve exactly what you're looking for in terms of your design. So let's take a look at how that looks like. So in this case, we have an integration between VSys, which is a tool in the IS portfolio, and Solid Edge and NX. Solid Edge wiring and harness has the same integration with Solid Edge, the CAD model, of course. So what we're doing here, essentially on the left, we have the schematics, and on the right-hand side, we have our harness. As you can see, the physical representation. We quickly import the information into NX. And from there, we're going to assign the components. The components that are known, identified, are assigned automatically. Components that have the same part number, we need to assign them manually. For example, splices. We're using the same type of splice for this specific application. That's why the manual assignment. But you can see the connections are identified automatically. And a very powerful feature is that it allows us to cross-select. So as the electrical engineers and the mechanical engineers are selecting different components, it highlights on each other's screen. So the mechanical can select a component and it highlights in the electrical, in VSys, for example, in this application, but that's essentially cross-selection. And you can see how it cross-highlights automatically in the other screen as well. And other thing is essentially to exchange wire length. We can see that this wire has no length, but if we select the same wire in the actual representation, we can see the wire length. So we're going to exchange the data between the two softwares, and just with a click of a button, now we have the wire length information inside the tool, which allows us to do a detailed analysis and calculate the voltage drops. The final step after that, of course, is to send the information, the finalized CAD model, to produce the harness, or to produce the actual nail board or form board, depending on how you'd like to name it. So again, let's see how that looks like. We have our components in NX with the components assigned, defined, and we're simply going to establish the connection mode between the two. And as you can see, we don't have any connections yet because this information, we're going to bring it into the electrical tool. We're going to make sure that it's using the correct format to interface, which is PLM XML. And just like that, once the mode is established, we're going to import the harness. The tool immediately asks you for the type of flattening required. For example, in this case, we're going to use 2D flattening, which is just selecting that. And it's done. We have our harness imported automatically into the tool. And again, cross selection is available. Once we select, it highlights in both screens. Okay. Now, this is a very powerful tool. It saves time in the design and even in exchanging data between different tools or different teams in the design itself. Now, we've looked at the ECAD-MCAD. Now let's look at the automation functionalities available in Solid Edge wiring and harness. For example, in this case, we're going to make sure that we add more components to our wiring design. For example, here, the bottom, this is our harness, and as you can see, it's partially completed. It's missing a few components which we added in the wiring. Now we just need to assign them to this harness and synchronize the information so we can bring everything over into the wiring, from the wiring to the harness. So going back to the wiring design, we're gonna make sure that the components here at the lower of the diagram, they have a specific description, which is the name of the harness that we're designing, which is the primary harness in this case. So we're just going to make sure that all the components have that specific property set. And we're going to do the same thing for wires, connectors, and devices, just to make sure that everything goes directly into that specific harness. Once that is done, Gonna save the project, close the wiring, and synchronize the two. So this is going to bring over all the information that we just added to the wiring automatically to the harness, so we don't have to start from scratch. And as we zoom in, you can see the new connectors, components, and splices have been added to the harness. All we have to do now is just move them out of the way and manually place them to the locations that we want. And once that is done, we're going to start placing them in the locations we want, in the location in the harness. Yeah. We're also going to specify the nodal positions of the splices. And we're going to use solid edge wiring harness native harness manipulation tools to quickly and on the fly organize our harness in a better view, just to make things a little bit better that adheres to a company standard. If you have a standard for the minimum bends and stuff like that, you can also optimize, and you can use the automations, for example, here to apply the styles. So we're going to look at assigning part numbers, which is an automation based on the properties that we assign. Just with a click of a button, we selected the part numbers for all our connectors based on the information that we provided or that we brought over from the wiring harness. We're going to do the same thing for the wire length. We're going to let solid edge wiring and harness to automatically calculate wire lengths for us. Again, just with the automation, we can use the auto calculation of wire length. For cavity components, we have the option of assigning them manually to component by component. For example, in this case, we're just assigning to this connector, which is the brake light left on the left-hand side. And you can see the terminal brought over and the table populated. Or we can assign it to all components at the same time and using the cavity components and leveraging the definitions that we assigned in the component database. So this is how the digital thread continues from your data library, from your library database, all the way to your design, whether in harness and in wiring. Now, the last part is to highlight the reporting. And reporting is extremely important because we need to think about how much time you spend in designing documents, such as the bill of material, the wire list, and part list. And how do you share these documents with your customers, with your OEMs, with your team members, and how do you exchange this data? So let's jump back into Solid Edge and see the reporting functionality together. So we're going to use the exact same design, just working on the same design, finishing the design. From the workflow tab in Solid Edge Wiring and Harness, we have the reports. So you have either built-in reports or you can build your own reports. So let's see the reports that are already existing in Solid Edge Wiring and Harness. For example, the complete bill of material, which you can generate on the fly. And you have a list of all the components, the description, part numbers, supplier part numbers, and the quantity of those components. You can save the report, you can print it directly, or you can even send it to your colleague. You can also see, for example, the separate bill of material, which breaks down things based on the groups that you define in the database: connectors, terminals, wires, and so on. And again, all of this is on the fly in Solid Edge Wiring and Harnessing. It doesn't need any type of additional licensing or any extra cost. The same thing again for wire list, where you have the specs, you have the name of all the wires, where it's coming from, connecting to which component, which cavity, which device, which pin. And again, all those reports are on the fly. And here we're looking at the harness wire list. It's just a more detailed list of the wires, all the connectors, the colors, the length, the part numbers of the wires, and all the terminals connected to. The other thing, we can build our own reports. So for example, here we would like to build a very simple report that shows us from two components. We just want to take a look at the wires and generate a report that tells us each wire is going from which component to which component. And we can include other components as well, if other categories or other groups of components if you'd like. So the first one, we're going to assign the name of the wire, and we're going to change it to a wire. And you can select from different types. So we're gonna go to wires, and we have a list of all the wire names. And then we're gonna go and set this to from an attribute which we want the wire part number to be added to the report, or for example here we have going to the common tab and then assigning the wire part number. And as you can see, all the wires that have part numbers assigned are automatically imported into the report. Now we're going to add the same thing, other two columns. One is going to be from, which is we can control whether it's the component name, the component pin, and we have the selection to do it, of course. So we're going to use the component name. And as you can see, a list automatically populates. And for another column, for column number 3, we're going to assign the 2. So from component, we need to specify the specific cavity in that component. As you can see, all the wires going to those components have been filtered out. And the last thing we're going to do, assign a 2, which is a function to this wire goes to which component. And we're going to add another column that tells us the cavity of the component. So we've created a report that tells us the wire name, the part number of the wire, where it's coming from, the component, the pin, which component it's going to, and the pin that it terminates in the other component. Once we generated the report, we can customize the name, we can add, give it a description, and in this case, we're just gonna call it from to. Once that is done, we're gonna save the report, and now let's see how we can generate our report in solid edge wiring and harness by simply going to the reports, and it's going to be listed in one of the predefined reports, which is from to. And then simply view report. You can share it with your customers. You can save it directly, and it's very easy to create your component, to create your own reports if the predefined reports don't exactly agree with your company standards. So it's a very useful tool that helps us, that gives us the opportunity to address the challenges of these complexities that we find as a result of evolution. So let's see, where exactly do we encounter such challenges, in which industries, to be just to try to be more specific. In automotive and transportation industry, we find many applications for such evolutions, and where we can exchange ECAD and MCAD information. For example, here we're designing a harness for a sound system that goes on the door. You have the inlines that break between the door and the body of the car itself. You have the different connectors, other going from the mirror control, moving to the window control, to locking all the doors around, and how we can exchange and assign those components. And again, cross selection is always available if you would like. So that was an example from the automotive and transportation industry. Let's take a look at another example from the aerospace and defense area. Again, similar thing, where you have, regardless of the complexity of the model, you have your electrical representation, physical representation in the actual model, and you can simply connect that with your electrical team, assign your components, assign the connections, and you can see automatically everything brought over. And again, you can cross select and select. So this allows you to communicate data between different designs and different teams at the same time. And you can see all this information generated just by the database that you provided in the application. So it's a very powerful feature to use and leverage. Another example of the same industry or the same challenge is the electronics industry. So where, for example, here we can see solid edge wiring and harness working with solid edge, which is the same exact application. We're doing cross selection, and you can see how it highlights in solid edge wiring and harness, and how it highlights in solid edge. So what we're doing is we're trying to synchronize the data bit for this specific control panel. So the applications that we can go on and on about those applications in all different types of industries and in all different industries. And for example, such industries can go from the marine industry, the heavy equipment or heavy machinery or industrial machinery industries, or even the medical industries. So the complexity that comes as a result of evolution, we can witness it in virtually all industries. And to be able to cope with those challenges, with this evolution, we need to have a set of tools that allows us to innovate. And at the end of the day, we don't want to be just like the horse technicians and horse carriage at the beginning of the slides. We need to catch up with the evolution. We need to maintain and update our technologies. So the electrical content is always increasing, regardless of the industry and the application. This increases the cost of the initial design, increases the overall design time and complexity. And similarly, every time, as we mentioned, you make a change to the design, there is a risk associated with that change. So solid edge wiring and harness addresses those challenges by allowing the user to automate the design workflow, to collaborate different multidisciplinary teams and departments, and reduce your risk, or your design risk and design cycles, and essentially verify your design and make sure that you're producing a design with the least amount of risk possible. Solid edge wiring and harness provides functionalities that help engineers deliver rapid, right from the first time, error-free electrical and harness designs through automation, analysis, and a wide variety of time-saving features. With that, we reach the end of our presentation, and we would like to open the door for any questions you might have. Thank you.
All right, thank you, Mo. Good. You can post any questions you might have in the chat window, or you can feel free to email me. My email address is in the lower right corner, lower left corner, and we saw a lot of information there. There was a portion of it where we were showing the CAD model coming from NX into Solid Edge. That's the same exact mechanism from from NX into Solid Edge wire harness. It's the same thing if you're using Solid Edge as your MCAD tool, or virtually any CAD tool. So we appreciate your attendance and focus, and this recording will be available for replays and to everyone that signed up. And so we appreciate your interest and time. And Anthony is on the line. Not sure if any questions on your end, Anthony? Are you there? Okay.
I'm here. I did notice a couple questions come through that I've attempted to answer during the presentation. If I've missed any, or if you have any more, as Rick said, feel free to email him and they'll get passed along to the team, and we'll get back to you as soon as possible. And of course, we'll share any questions and answers that we get with all of the attendees.
Oh, great. All right. Well, I think we'll wrap here. Thanks again, everyone. Try to stay cool and enjoy the rest of your day. Thank you very much.